are talking about direct variation. So any guesses what goes in our first blank?
Direct variation.
Good.
So are you recording?
Yes, I am.
Oh, I should not.
Okay, so direct variation is a special type of linear relationship that can be written in the form of y equals k times x, where k is the constant of variation. So basically, we need some constant where we normally put our slope. So we need this to be increasing by some constant rate every time. Okay? So, here, it says determine if the relationship is a direct variation. If so, then write the equation. So we can use that same calculator method to do this. So I can bring up stat, edit. I want to fill in my list. So in list 1 we have 1, 3, 5. And in list 2, we have 6, 18, good. Okay, we press stat, calc 4, and we press enter on calculate. And we have A equals 6 and B equals 0. So A is our slope, right? So we ended up with M equals 6 and B equals 0. So, if they want it in y equals k times x form, there can't be a plus b. Since ours is 0, not 6 times 0. If I wrote this as an equation, it would just be 6x. So is this a direct variation? Yes, because we had no value for b.
So there's no value for b in this direct variation.
Most likely, yes, because that means it's increasing by some constant rate. And if you look up here, it says the graph of a direct variation equation y equals k times x is aligned with the following properties. It passes through the origin, which means it didn't shift up or down, which is what we had here, right? And the slope of the line is k, some solid value. So this will increase by 6 every time. So we'll be going up 6 over 1, up 6 over 1 every time we plot a point. Okay? All right. So we can do the same thing. I can't fit it on here. There. We can do the same thing on number 2. So stat, edit. We need to change our list. My first list has what numbers? What's in my list 1?
I got some weird numbers.
Okay, my list 2 would be good. Stat, calc, 4. Right.
That's a weird number. Sounds down.
We got these decimals, right? Yeah. So, again, the A is what our slope is, so that tells us the M or the K in this type of equation, right? We're looking for direct variation, and this is our B. So, if I was to copy that down, I could round, so like approximately 0.964, right? And my B would be about 2.679, and along those lines. So, if my B is 2.679, did this go through the 0.00?
No.
No. So, is this a direct variation? No. This one is not a direct variation. It's not going to hurt you to write out direct variation.
Actually, it hurts my wrist, Miss Ray.
Does it? Maybe you need to exercise.
My wrist already hurts, so I'll stop playing the cold.
Okay. Number 3 says the number of hamburgers that can be made varies directly with the weight of ground beef that is used. 5 hamburgers can be produced for every 2 pounds of ground beef. Write a direct variation equation for the number of hamburgers Y that can be made in pounds from X pounds of ground beef. Then graph the relationship. So they told us that our Y value was what? Number of hamburgers. So this axis over here is our number of hamburgers. And they said that our x-axis is, right, pounds of ground beef. Okay, so if we are going to graph this, we just need a couple of points, right? So if we're showing that this is a direct variation, we would need it to go through the point 0, 0. So if x is 0, that means we have 0 pounds of ground beef. If I have 0 pounds of ground beef, how many hamburgers can I make? 0. Okay, so we have our first coordinate point. Then it says 5 hamburgers can be produced with every 2 pounds of ground beef. So we have 5 burgers, 2 pounds. Which one is the x value, the 5 or 2? 2, because it's the pounds. Exactly. So there we go. We've already got 2 points right there. So if I want to come up with an equation for this, we could just put these 2 values in, or we could plot these 2 points. So 0, 0. And then I go over 2, up 1, 2, 3, 4, 5. Right? And that should be our constant, right? Every time I add 2 pounds of meat, I make 5 more patties. Here's our graph. Right?
What?
So that's all they had asked us to do, was to graph this relationship. All right. The back says the mass of a substance varies directly with the volume of the substance. 80 liters of the substance has a mass of 100 kilograms. What is the volume in liters of 3.2 kilograms of the substance? So we could do that thing. What'd you just do?
Jake, what did you do?
I was gonna show up on the video.
Loud bang noise.
Hey, wow, Jake, you don't even pick it up.
So we're going to make that same chart, but we have some x values and some y values. So remember, our x is the independent value. We've talked about that before, right? So would you say that the volume depends on the mass, or the mass depends on the volume?
No.
So depending on what your volume is, that's what tells you your mass. So our x values are the volume, our y values are the mass. So if my volume is 0, what is my mass?
1,000.
All right, and then it says for 80 liters, so when our volume is 80, our mass was what? Good. Yes, so we could put this in our calculator to come up with some equation. So my list 1 is going to have 0 and 80. And my list 2 is going to have 0 and 100. So stat, calc, 4. And here we go. Huh?
It's a direct.
It is a direct variation. How do we know?
B is 0.
Right, the B is 0. So I can come over here, and our M or our K was that A value, which was 1.25. So if I wanted to write that as the equation y equals K times X, well, we just found out our K was, right, so there's our equation. But we're not done, because it said, what is the volume in liters for this many kilograms of the substance? So, they said that we have this much of some substance, so we're going to plug that in for X. What is 1.25 times 3.2? Good. So I end up with y equals 4. So it said we were finding out how many liters. So we would have 4 liters, right? Good. Okay. Number 5 says the value of y varies directly with x. Which function represents the relationship between x and y when y equals 24 and x equals 18? Well, if it's a direct variation, then we know it goes through the origin. So that would be the point 0, 0. And they also said that when y is 24, x is 18. So there's 2 coordinate points. And we could put this in our calculator. Again. Or you could do it by hand.
Yes, it is.
You just cleared it.
0 and 18. And then 0 and 20.
Guess what? It's a direct variation.
How do you know it's a direct
Because
variation?
paper says.
Because the paper says so.
No, because the B is 0.
Right.
Because the paper says it.
It does.
So, I have that K was equal to 1.33 repeating, right? That 3 just keeps going and going. So remember, we like to write our slope as a fraction, so that tells us how much up and over to go. So how could I rewrite 1.3 repeating as a fraction?
Wait, that would be
133
over
over
100.
100.
3 over 1.
Huh?
3 over 1.
Not 3 over 1. We would have, yes, this 1 and 1 over 3. But we don't want it written like this either, right? We want it to be all one thing, so it tells us how much right, because I could rewrite 1 as 3 over 3. I add those 2 together, and I do get 4 over 3.
Where did you get 3 over 3?
3 over 3 is
The
the
one.
same as 1, so I just replace the 1 with a common denominator. So we get that y equals 4/3 x. Alright, last one says the amount of blood in a person's body varies directly with the body weight. A person who weighs 160 pounds has 4.6 quarts of blood. What equation could be used to represent this relationship to find how many quarts of blood are in a body that weighs 206.7 pounds? So, the blood depends on the weight. So that tells us the blood's going to be our y and the weight is our x because the blood depends on x.
It does, doesn't it?
So if it says this is a direct variation, we know that if the body weighs 0 pounds, there is 0 blood.
Person's 160 and 4.6.
Right. So then they told us if a person was 160 pounds, that they had 4.6 quarts of blood. So we have some second point. So we said this is our weight, this is our blood, and we could plug that into our calculator, right?
We could. Couldn't
It is different.
It is direct, is that what you said? Because there's a 0 for B. And what is the K value that we get?
0.0087.
The A, the K, the M. So yes, we get 0.2875. Is that what you said, John?
Yeah.
Okay. So, if I wanted to write this as an equation, we said it was y equals k times x, and this is our k, right? So 0.02875x. Okay? And they want us to figure out how much blood there would be for a person that weighs this much. So we said weight was our x value. So we're going to take this weight right here and plug it in for x, yes. So I'm going to have y equals 0.02875 times 208.7. 0, 0, 1, 2, 0, 0, 0, like that.
No.
And that would be approximately how many quarts? That's what we're looking for. About 6 quarts of blood.